Hey guys, away. So for grade 12, the first chapter is arithmetic sequences. This chapter is just about, let me see what is about sequences and series. Yes, sequences and series. Right, but for this video, we're only going to talk about arithmetic sequences. And here, I want to unscare you for a bit. If, yeah, the word arithmetic sequence, is challenging your brain, do not be alarmed. Arithmetic sequences is exactly the same thing as your linear number patterns, right? Or a linear sequence, we can say, right? Everything is the same, right? You have a pattern which increases or decreases by a constant term, a term that is not changing. Or let me not say a term, but let me say a number. So the pattern increases or decreases by the same number through all out, right? For example, it increases by 2 or it decreases by 5, right? Always and forever. Then you know you have a linear number pattern, right? And this is exactly arithmetic sequences. But then for grade 12, the formula, we start using a new formula, and it's very, very fast, but you don't have to remember in grade 10 and 11, right? You first have to find, we used y equals to mx plus c, right? And then, oh, not this not this one, let me not say this. We used to use a formula that was like, this is an plus, let me say d, right? And d would be your common difference, and this, right, was a term. I think to find it, we did something like first term minus common difference, something like that. But yeah, in grade 12 we uses a different formula, which is this one that we have here. So this is a tn, right? Term number, and then right here you have your first term. So a in this case is the first term, right? First term in the number pattern, right? Meaning the number that starts the pattern. Right? And of course, in this case, that number is 2, and in the pattern I have here, the number is minus 15. So a is the first number of your pattern or your sequence. Ne? And then another thing we have to worry about is this one, but it's quite simple. It's common difference. Ne? Common difference, you just subtract the two consecutive terms, right? Or the two consecutive numbers in your number pattern or your sequence. And then the answer you get, right, in a linear sequence or in an arithmetic sequence, the number you get, it has to be the same through all out, right? Yeah, if it's not the same, you're not dealing with a linear. But soon as it's the same, you are dealing with an arithmetic sequence, and you can definitely use this formula. Right, so I'm going to show you with a couple of examples how we uses that formula to, yeah, to get a lot done. Cool. And so we have a pattern here, of course, and when you have a pattern, one of the questions that would usually come, they would say, what are the next three numbers, right? So you see here we have 4, we have 2, then 6, then 10, then 14, right? From here you see that the difference between all these terms, let's go, 6 minus 2, that is what? 4. 10 minus 6, that is 4. 14 minus 10, also 4. 40, 18 minus 4, 18 minus 14, that is also 4, right? So you are seeing that the pattern increases by 4 each and every time. That means to get the next one, you would say 18 plus 4, 22. So here it is 22, and then so you have 22, right? 22, you add another 4, you have 26, right? 26, you add another 4, right, which is 30. And so right there you have your next three numbers, right, in this sequence. And then of course the follow-up question would usually be find the general oh no, yeah, they would say find Tn, right? So to find Tn, then we would just say Tn. Then what is a? A is the first number in our sequence, so we put 2 here instead, plus, and we leave it as it is, and then 4, which is our common denominator, common difference, not common denominator. 2, then you multiply 4 and n, you get 4n. Here you will have minus 4, right? And when you do the math, you have 4n minus 2, right? So let us test it out. Let us test it out. So you have 4 multiplied by a particular number minus 2, right? Let's substitute the number 1. When we substitute 1, we get 2. Okay, let's substitute 4. 4, we get 14. How about 5? Let's see. 1, 2, 3, 4, 5. So let's say this is 1, 2, 3, 4, 5, 6, 7. I want to see 7. 7. We get in 26. Right, so it works. It works. Right. Let us use it again for the next problem. The next problem, they are saying, is this an arithmetic sequence? But of course, yeah, it is. But let's find out why it actually is. Let us find out why it is so. Maybe. Cool. So first thing, we're going to find the difference between the consecutive. Just these two, right? They can tell us. And how will we know is if the difference between consecutive numbers is the same. So first thing first, we would say minus 11, minus 11, minus 15. Right? We get 4. Let's go again. Minus 7 minus 11, and we get 4. Right? So we are aware that from here it seems like each to get the next term you have to add the your current term by 4, right? Or perhaps to get the next number you have to add the number you have now by 4, right? That's how you will get the next number. And because we have a common difference here, you would conclude that this is an arithmetic sequence. So we're done with this guy, and then we find the formula, right? So the formula, it's very easy. It's very easy. You have a plus n minus 1, right? And then d. So this is going to be a, the first number, or which is minus 15, plus n minus 1, 4. You have minus 4n minus 4, right? So then this becomes 4n minus 19. All right, so we're going to use this formula for n minus 19. Perhaps we can use it to test all these 3 terms we have, to say 1, no. 1, we get minus 15. 2, we get minus 11. And 3, we get minus 7, meaning it works. All right. And then to make it a bit trickier, we can say how many terms, right? We can say how many terms are in the sequence, right? Yeah, how many terms are in the sequence. And for this question, we go back to look at our pattern. What is the last number? So you have the last number, and the last number is 173. So we're gonna find the value of n, right? The term number, right? Yeah, the term number for the last term value. And then that term number is going to tell us how many numbers we have, or how many terms we have in the sequence. So with your formula, you would say 173 4n minus 19. So this 19 minus 19 goes this side. You have positive 19 plus 173, then 4n. So 19 plus 173, you're getting 192. Okay, let's divide by 4. So that 192 divided by 4, we get 48, right? So that means you have 48 terms in your sequence. Né? Let's just test it out. Remember, we have 4n minus 19. Né? So we're going to substitute 48 and we must get 173. Voila. You see. So, yeah, the formula works. The formula works. Cool stuff. Now we have a very, very interesting example. Ooh. But I will tell you the truth, ne? I will tell you the truth. I don't know if patterns scares you at all, but like I hope they do not. But if they do, I just wanna say this is one chapter where you can get free marks, like easy marks. I'm telling you, man. Okay, so here we have the term numbers this side and the term values, ne? So we're gonna have to find the unknown variables, right? We have the first one, the second one, the third one, and the fourth one, as well as the fifth one. Right? It's crazy here, actually. I don't know what happened here, but I will check. I will check. Right. So, because I'm gonna just say this, so of course this video is specifically about the arithmetic sequences. So you don't have to ask yourself if whether this number pattern that we have here, or this sequence is a arithmetic one or not. It is. So cool. So we can just find the difference between the two, right, which is going to be 2, right? And we know this is what? This is going to be D, right? And 3 is going to be A. And with just these two, we are sorted in a way. Yeah. So you just go to, you say Tn equals to A plus n minus 1 D. Ne? You have A, which is 3. D, what is D? It's 2. Then you have 2n minus 2 plus 3. Then you have 2n plus 1. Yebo. We can test it just to be sure, right? Plus 1. Substitute 1, we get 3, 2, we get 5. And that is cool. That means our formula works. Ne? And then for P, we substitute 3, right? Because the term number for P is 3. Once we substitute it, we get 7, and therefore we know that P equals to 7. How about Q, right? So Q, you have Tn equals to 2n plus 1, right? You have 15, you have 2q plus 1. And then you transpose the 1, it becomes 15 minus 1, 2q, here you have 14, and therefore q is going to be what? Q is going to be 7. So yeah, this gentleman equals to 7. Ne? Cool stuff. And for R, you're gonna do exactly the same thing you did, right? Let's do it here. You would say 71, I believe it's 71, yes. 71 equals to 2n plus 1. Yeah. From here, it's just about solving for n. Perhaps instead of n, I can substitute r, right? And I have 71 minus 1, 2r, 70. And therefore, r equals to 35. You see, r equals to 35. Let me just investigate here. What was I thinking for the last one, right?